when we look at the graphs of functions, we can place all graphs into 4 categories. And the first one is the category smooth continuous curves. There are lots of these. So that's the first category. An example will be a curve that maybe looks something a bit like that. So there's my x and my y, and that would be the graph of y equals x cubed minus 3x squared. Okay, so that's pretty straightforward. It's smooth, it's continuous, and it's got a curve. The next category are what we call piecewise. And these are continuous and they look a little bit algebraic, like y equals 2 for x is less than 3, and y equals x minus 1 for x is greater than or equal to 3. Piecewise, another name I think some of you may have known them as hybrid. So hybrid or piecewise functions that are continuous. Now here's our domain. So it says for all the values of x less than 3, the graph is going to look like y equals 2. So in other words, here's 3. So this is my critical point where the function will change from looking like y equals 2. Now y equals 2 just goes through 2 units up. And then at the point 3 it changes. And after that, it looks like x minus 1. Now, x minus 1 is a graph that goes through like this, and it goes like that. So x minus 1, it doesn't behave like x minus 1 when x is less than 3. So all the values less than that, the function will just look like the y equals 2. So there's 2. If you like, that would go through, dotted line would go through -1, but this is the graph, not the dotted line, so I'm just showing you what it would look like. So that's the graph of y equals x minus 1, but this is the critical point. It only acts like that graph from 3 onwards. Alright, so that's a piecewise or hybrid function that is continuous. A piecewise discontinuous graph would be like y equals 5 for x is less than 3, and y equals x minus 1 for x is greater than or equal to 3. Okay, so what's that going to look like? So once again, if we drew our axes, and we go up 5 units, so everywhere up until 3, it's going to look like y equals 5. I should go through that. So everywhere up until that, and then after it gets to that point, it's going to look like y equals x minus 1. So that would be the graph of the function. I'll put some axes on here. And you can see why it is now discontinuous. There's a gap in there. It is not, it's a piecewise function still, just like up here, but there is a gap in the graph, so it is discontinuous. And we'll spend a bit more time a little bit later in the course looking at tests and that for continuous and discontinuous. And the last one, so we've got 1, 2, 3 categories so far. So we've got curves that are not functions. And just because we use the word curves, curves can be straight lines. So don't get confused with that. It doesn't have to be a nice shape like that. This is a curve. From there to there is a curve. So curves that are not continuous. If we've got y squared equals x, we've already looked at that. If we've got x squared equals y, it is just the parabola that goes like that. But y squared equals x is where it goes around the x-axis. So we've got that. So there's the graph of y squared equals x. That is not a function because if you go back to what we said was one of the tests for a function, is that given one x value, there can only be one y value. If I had this value here of x, there are two corresponding y values. So if you like, go back to the mapping. Say this is the point 9. So given one x value of 9, so here's my x and here's my y, there are two values of y. Now what would those 2 points be? You've got x here, a value of 9, so 9 equals y squared. What have you got to square to get 9? Well, there are two values. There is -3 and there's +3. So that's some sort of understanding as to why y squared equals x is not a function, because given one x value, you can have two y values. A very simple test is called the vertical. If you've got a graph, the vertical line test. And that just says you can, if you can draw a line anywhere, a vertical line anywhere to cut the graph, if it cuts the graph in 2 spots or more spots, then it is not a function. And that clearly, there are a number of vertical lines I can draw here, an infinite number actually of vertical lines, but you only have to have one vertical line, and if it cuts the graph in 2 or more spots, well, it is not a function. Now, before we finish this, just don't get confused with y equals the square root of x. That is a function. Why is that a function and that not a function? This is the total graph all the way around there. This is simply the top half of the graph. It is just the positive. If I took the square root of both sides, I'd get y equals plus the square root of x, y equals minus the square root of x. So y equals plus the square root of x is simply the top part of that graph. Now, I can draw an infinite number of vertical lines here and it'll never cut the graph more than in one position, one spot. So that is a function. So that's a little bit aside of this up here. So don't get confused between those two there. So 4 different categories of functions. We've got smooth continuous line curves. Curves also can be straight lines. So that's a smooth continuous curve. Hybrid is where you've got 2 or more different pieces that go to make up the graph, and you define it over the different domains. piecewise discontinuous, and curves that are not functions.